Good day, everyone. Welcome to lecture number 17 of this lecture series on microprocessor 8085. In this particular lecture, we will discuss about a technique called direct memory access. And for this direct memory access, we need a controller, and we will study about one such controller, which is Intel's 8237 DMA controller. So first we will see what is direct memory access and how it can be done in our microprocessor 8085. So direct memory access, which is also written as DMA, it is a technique. It is an input-output technique. Input-output technique means that if I have to enter some data into the microprocessor's memory or get some data from the microprocessor's memory. So direct memory access is an input-output technique, and it is used, this particular technique is used for high-speed data transfer. Data transfer. Okay. For example, if I have to transfer data between system memory and some other device, for example, the other device may be a USB stick or a floppy disk. So if I have to do a transfer from memory to a floppy disk, then in that scenario, I will require a DMA. Okay. So now somebody will say, why we require a DMA? Why can't we achieve the same objective using a microprocessor? So what I mean to say, for example, this is a microprocessor. Okay. Or any processor, this is its memory. And let's say I have connected some external device, so let's say floppy disk or USB, okay, to this microprocessor. Now, if I want to transfer data from this USB to the memory, then my microprocessor handles the data transfer, okay. So if we allow microprocessor to handle the data transfer, this particular data transfer is relatively slow. Okay. So what I am saying, if we make microprocessor to handle the data transfer from USB, from external device to memory, that data transfer is relatively slow. Now somebody will say, why it is slow? It is slow because microprocessor is doing other tasks as well. Okay, so if it transfers 1 byte, then it has to wait for some other operations to complete, then only it can transfer the other byte. So because of this slow speed of data transfer in relation with the microprocessor, we need a technique such that we can have high speed data transfers. Okay, so this scheme of high speed data transfer is achieved using a technique called direct memory access. So what is there in the direct memory access? In direct memory access, microprocessor, what it does, it releases the control of data and address bus. So see, here we know that the control of data and control of address and data bus is with the microprocessor. But if we want high speed data transfer, we want that this control and data buses and address bus, what we want that, see, let's suppose we have a USB and I want to transfer data from this USB to memory. Okay, in between we have a microprocessor. So USB has to send data to microprocessor, then microprocessor sends to memory. Okay, and as I said, that microprocessor sending this data via a microprocessor is relatively slow. Okay, and you have to also keep this in mind that microprocessor transfers data to memory via address and control buses, address and data bus. Okay, because that address and data bus is under the control of microprocessor. Fine. So USB has to send data to microprocessor, microprocessor sends to memory. But this process is relatively slow. Why? For every transfer, microprocessor has to do read and write. Not only read and write, it is like executing every instruction. So executing every instruction requires fetching the instruction and then executing the instruction. And it takes a lot of time because it sometimes makes this USB to wait for other operations to complete. What we want high-speed data transfer. So how can we achieve the high-speed data transfer? We want that somehow this microprocessor should be taken out from this path. Okay, so if we take microprocessor out of this path, we have a USB and we have a memory. Now we have taken this microprocessor out of this path, so USB can directly send data to memory, and this data transfer is very fast. But how we will take this microprocessor out of this picture? Okay, that taking this microprocessor out of this picture comes under the direct memory access. So what is happening? So in direct memory access, microprocessor releases the control of data and address bus. This data and address bus, it releases its control. So microprocessor is not in control of address and data bus. Okay, and after releasing this the control of data and access bus, it gives this control to a device called Dma controller. So now let's see. So we are having USB. So normal operation was we were having USB communicates with microprocessor then communicates with memory. Now we are saying we have this device USB, and after this we have a DMA controller. Okay, and after this we have memory. Okay, so this DMA controller, it takes the control of address and data bus. Now, if I have to transfer data from USB to memory, I have to request a DMA controller. Here, I have to request a microprocessor. Okay, so for every transfer, I have to request a microprocessor. So here, my USB will inform DMA controller that I have to transfer data to the memory. This DMA controller first informs the microprocessor. It tells the microprocessor that I requires the address and data bus. Okay, and after getting the address and data bus, it takes this one takes the control of data transfer. Okay, so let me repeat this scenario. So what we are having, we were having a USB, we were having a memory. So this memory was connected to microprocessor via data and address bus. So there were data bus and address bus. So this data bus and address bus is under the control of microprocessor. Now, if we have a controller, which is called a DMA controller. So if an external device has to transfer huge amount of data, it will inform this DMA controller that I want to do bulk transfer of data to memory. This DMA controller requests microprocessor. So it sends a request. What request? It sends a DMA request. DMA request means that it will ask this microprocessor that please give this data bus and address bus to me, so that I can directly use this data bus and address bus and send data from USB to memory. without taking your any help. So what this microprocessor does, when it receives the DMA request, in the next cycle, it sends an acknowledgement to a DMA controller. Okay, that yes, now you can take the control of data bus and address bus. After taking the control of data bus and address bus, now DMA controller can easily transfer data through data bus and address bus to the memory. But in the meantime, this microprocessor cannot use data bus and address bus. So after completing this data transfer, what this DMA controller does, so when it has sent a request, sending a request means it is sending a signal that is one. Okay, it sends a one signal through a pin. So here we have one pin on microprocessor. That pin is called hold. So when my microprocessor receives a one signal through a hold, it means that it is receiving a DMA request. Okay, and it is sending an acknowledgement through another pin which is available on this microprocessor, that is HLDA, hold acknowledgement. Hold acknowledgement means that you can do the data transfer, that this data bus and address bus is now under your control. So this DMA controller, after completing the data transfer, it makes this particular signal, this hold signal, as 0. 0 means now it has completed. Then microprocessor can use the data bus and address bus. Okay, so what is happening in the DMA? So if somebody says what is a DMA, direct memory access, so you can say that in direct memory access, the microprocessor releases the control of the buses and gives the control to a device, and that particular device is called a DMA controller. And you have to remember that DMA controller can only do data transfer. Okay, it cannot perform any other operation. For example, microprocessor is performing many other operations as well, but data transfer, we can say that DMA controller is like a microprocessor, but only does data transfer. Okay, it cannot perform any other operation. So that means this DMA controller manages data transfer between memory and a peripheral under its control. So DMA controls this data transfer from this peripheral device to the memory. And as I said, that whenever we have to do this DMA transfer, the DMA controller sends a request to microprocessor through a hold pin, and microprocessor sends an acknowledgement through an HLDA pin, hold acknowledgement. So this particular pin, hold pin, this is an active high input signal to the 8085 microprocessor. So if this is my microprocessor 8085 and it has this pin, hold pin, and it has another pin, hold acknowledgement. So this is an input pin. Input pin means that from this pin, it receives a request. Okay, and this is, as I said, this is an active high input signal. Okay, so, and whenever my microprocessor receives a signal, high signal through this particular pin, that means it is getting a request from a DMA controller, or we can say it is getting a request from another master, so that this master can take the control of data and address buses. So when my microprocessor is ready to give the access to DMA controller, it sends an acknowledgement to a DMA controller through this particular pin, HLDA. So HLDA is an output pin on microprocessor 8085, and hold is an input pin from microprocessor 80 to microprocessor 8085. Okay. So what I am saying here, that a DMA controller uses these particular signals. What are these signals? One is hold and another is hold acknowledgement. So hold, as I said, it means that I need the access of control and databases. Hold acknowledgement means that you can get the control. I have given you the control of data and address buses. So a DMA controller uses these particular signals as if it were a peripheral requesting the microprocessor for the control of the buses. Okay. And as you have to keep this in mind, that once the DMA controller gets the control, it plays the role of processor for data transfer. So that means the role that was to be played by microprocessor, that role will now be played by a DMA controller. Okay. So this DMA controller, what it gets to do the DMA operation, it gets data bus, control of data bus, control of address bus, control of read-write signals. Okay. And also it should have the control signals to disable. So let me repeat this, the fourth point, what control signal is. So this DMA controller, it acts as a peripheral device as well as a, so peripheral device means slave device, as well as a master device. Master means that the role of processor. So initially DMA controller is a slave device. Slave device means that it works under the control of processor. So it has to send a request to the microprocessor. After getting the access of the data and address buses, it acts as a master device. Master device means that it acts as it has the role of processor to do the data transfer. So the fourth is that it should have the control signals to disable its role as a peripheral device and to enable its role as a processor for data transfer. Processor for data transfer. Okay. This process is called, so changing role from peripheral device to data processor device, it is also called switching from slave mode to master mode. Slave mode to master mode. Fine. So we can say that DMA controller is a processor. So let me write it here. DMA controller is a processor capable only of copying data at high speed from one location to another. Okay. So this completes the discussion about the DMA and the requirement of a DMA controller. So as I said, DMA is a technique of high-speed data transfer And this high-speed data transfer can be done with the help of DMA controller. In direct memory access, DMA controller gets the access of data bus and control bus, and then it can directly transfer data from the peripheral device to the memory without the involvement of microprocessor. So DMA, we can say a direct transfer of data from a peripheral device to a memory without the involvement of microprocessor. And this can be achieved with the help of DMA controller. And on the microprocessor, we require two pins to achieve this objective. One is hold and another is HLDA. Okay, fine. Now, our discussion in this particular lecture will be to discuss one of the DMA controller. There are multiple DMA controllers available, but we will study one controller that can be integrated with microprocessor 8085 to achieve DMA operations. So one such controller is Intel's 8237 DMA controller. Okay, we will discuss this DMA controller, this particular controller, and we will see how this is used to achieve the objective of direct memory transfer, direct memory access. Okay, so we will discuss this controller, but you have to remember, we won't discuss all the components of this controller. We will only discuss those components which are necessary to understand the direct memory access in microprocessor 8085. So let's discuss about this particular controller, that is 8237 DMA controller. So as I have already said that we will only discuss few details related to this DMA controller. We won't discuss this in great detail, but we will discuss only those details that are necessary to understand its operation in relation to microprocessor 8085. So as already said that this 8237, it is a programmable. So that means we can program it. We can write code in this particular controller using the microprocessor 8085. It is a programmable direct memory access controller. And this particular chip or this particular controller has 40 pins. Okay, like microprocessor 8085 that has 40 pins, this one also has 40 pins. Okay, and this controller has 4 independent channels for data transfer. Okay, so it has 4 independent channels that are used to transfer data from the external device to the memory, and each such channel is capable of transferring 64 kilobytes of memory, kilobytes of data. And as I said that this DMA controller, any DMA controller, it has 2 functionalities. One, sometimes it acts as an input output device. So that means microprocessor sends the data to the DMA controller. In that case, DMA is an output device. Sometimes DMA sends data to the microcontroller, and that particular time it is an input device. So sometimes it is working as an input output device under the control of microprocessor 8085. So in that particular scenario, it is considered as a slave. Okay, and sometimes it acts as a processor for data transfer. In that particular scenario, it is called master. So when it is taking the job of a processor, when we have to perform a DMA operation, and in that particular scenario, it acts as a processor, and the peripheral device So that peripheral device may be a floppy disk, USB disk, and an internal memory. This data transfer helps with the help of this particular DMA controller, which acts as a master in that particular scenario. Since it has two functionalities, so it has some pins that are bidirectional. Bidirectional means, what it means that sometimes they act as an input pins and sometimes they act as an output pins. For example, when it is working as an input output device, then the pins will be as input pins. And when it is working as a processor, and that particular time, those pins will act as a output pins. So some pins are bidirectional in nature, and other pins have only one direction, either input pins or output pins. But there are some pins that are both input pins as well as output pins. Fine. So first we won't discuss all the 40 pins of this DMA controller, but we should know what are the pins, and we should also know what is the internal structure of this particular DMA controller. Okay. So first thing is that it has address pins, A0 to A7. It has data pins, so they are written as DB0 to DB7. So these are the data pins. Okay. Apart from that, it has DMA request pins. And these are 4 in number. They are written as DREQ0 to DREQ. So what are these pins? So as I said that every DMA controller has 4 independent channels to transfer data. So whenever some peripheral device has to do a DMA transfer, it sends a request to a DMA controller through these pins. Then DMA controller can use one of the 4 available channels depending upon the request, and it will use that channel to transfer data from the peripheral device to the memory. Okay, so these are 4 independent input signals to the DMA, and these pins are used to receive the requests from the peripheral devices. Then fourth, now let's suppose it has, our microprocessor has received a request, our DMA controller has received a request from a peripheral device, then it should acknowledge also to the peripheral device that you can do the transfer. Okay, so there are pins, these pins, acknowledgement pins. So these should also be 4 pins because these are 4 requests. So we have 4 pins. These are also called a DMA acknowledgement. So what I am saying, let's suppose this was my processor, microprocessor 8085. This was my DMA controller. Okay. This is a peripheral device, and this is a memory. Fine. Now what will happen if peripheral device has to do data transfer, DMA access to the memory? It will first send a request to DMA controller via one of these signals, these pins, one of these pins. So when my DMA controller receives a request, DMA request from a peripheral device, it sends a request to 8085 DMA request. And we know that in 8085 we have hold pin to receive this particular input. Okay, so DMA should also have a pin through which it will send this particular request. And in DMA controller we have one pin, that is HRQ. So it sends a high request through this pin HRQ And this pin is connected to hold pin of microprocessor 8085. So microprocessor 8085 will receive this request. After receiving the request, it will give the access to DMA controller, that now you can do the DMA transfer. And we know that it will send an acknowledgement. And through which pin? HLDA pin, hold acknowledgement pin of microprocessor 8085. So likewise, we should have such a pin in DMA controller also, and in DMA controller we have that pin as HLDA pin. So you can see the HLDA pin in 8085 is an output pin, and an HLDA pin in DMA controller is an input pin. So after receiving the acknowledgement from the microprocessor 8085, it then sends the acknowledgement to the peripheral device through one of these pins. So it is DMA acknowledgement. Then we can do the data transfer. Okay. So apart from these pins, what are the other pins? As I said, there is HRQ and HLDA pin. These two pins also. Sixth category is there are some control pins, for example, memory read and memory write. There are also some other pins, input read and input write, input output read and input output write. These are also some of the pins. Okay, fine. So these are some necessary pins that we have to discuss. There are many other pins. For example, there is a reset pin, there is a ready pin, there is clock pin, there is end of process pin. So we won't be discussing those pins here, but these are the important pins that everyone should remember that are there in 8237 DMA controller. So this was about the pins. What are the different pins that are there in this DMA controller? Now, what is the internal structure, or what are the registers that are there in the DMA controller? Okay. So in DMA controller, inside DMA controller, we have total 16 registers. There are total 16 registers. And you can see that every register can be represented by 4 bits. Okay. So the first register is the channel 0 memory address register. What it means, for example, if I have to send data, let's suppose I have to perform the DMA operation. So that means I have to take data from the peripheral device and send that data to the memory. But in the memory itself, I should know at which location I have to put the data. And the address of that location is stored in the DMA controller in this particular register, Ch0 MAR. Why Ch0? Because there are 4 different channels. So we will have 4 different memory address registers. So we can send data to 4 different locations in the memory. And we should also know how much data my floppy disk or my peripheral device can send to the memory. We should not allow it to do the DMA operation indefinitely. We should limit the number of words it can send in one go. So we have another register which is called Ch0 Count Register. So it counts the number of bytes it can send. Okay. So these are for channel 1, for channel 0. And we know how many channels are there? 4 channels. So there will be these 2 registers for channel 1, channel 2, and channel 3. So it makes the total 8 registers. So this address is 0, this is 1, then we have 2, 3, 4, 5, 6, 7, 8. Then there are 8 more registers. For example, what are the registers? There are registers, for example, a write request register. There are registers such as read write status and command register. But those registers, we don't have to discuss those registers here. So we won't care about those registers. We will only consider these 8 registers that are useful to us. Okay, but I said that there are total 16 registers. Fine. And in our what I mean to say, in our DMA controller, these all are internal registers of microprocessor of DMA controller. Now, whenever my microprocessor knows that my DMA controller has to do the operation, it will do my microprocessor 8085. Before using the DMA controller, it has to initialize the controller. Initialize the controller, what does that mean? It means that microprocessor has to send the address on which the DMA controller can write. For example, DMA controller should not write on any address in the memory. It should only write in those addresses which it is given access by the microprocessor 8085. So this microprocessor 8085 sends this memory address register. Okay, so it will initialize this memory register and initialize it as registers as well. So there are initializations that are to be done before starting any operation. Okay. So not only in the initialization, we not only provide the address, we also set the priority of the channels. For example, since there are 4 channels, should we allow channel 0 to send first, channel 1, channel 2, or channel 3? Which one has the higher priority? That priority is also done with the help of this initialization. Also the count, the number of bytes that it is allowed to send to the memory, that is also initialized by the microprocessor 8085. So this initialization means that we have to program the controller. Program the controller means we have to program it, what it is allowed to do, and where it can do the operation, where it can perform the operation. So that is why the name is Programmable DMA controller. We can program this controller, but the programming of this controller, we won't discuss that programming in this particular lecture. So our aim now, because we are not discussing how we will program the controller, but we should know what is the general working procedure of DMA controller. For example, how 16-bit addresses are generated, how it is working. So we will discuss the complete working, or we can say DMA execution. So how it is performing this execution. So we are not going to discuss a slave mode. We will also only discuss the master mode. Master mode means when we have to perform the DMA operation. Okay. So the first job is when our peripheral device has to do a DMA operation. It sends peripheral device sends a DMA request to controller, and it can send a request to throw which pin? DRQ pin, either DRQ0, DRQ1, DRQ2, or DRQ3. Okay. Then the second is what will happen, what is done by the this DMA controller. So when DRQ has been received by the DMA controller, what it does, it sends, so DMA controller sends a request to microprocessor 8085, and controller sends through this particular pin request, and microprocessor 8085 receives through this particular pin. Okay. So after this microprocessor 8085 releases the buses, or we can say it gives the control of buses to this DMA controller and sends an acknowledgement to DMA controller. And 8085 sends through this particular pin acknowledgement, and DMA controller receives through this particular pin. After that, what will happen? So in the fourth step, what our DMA controller has to do, DMA controller has to place the address on the address bus. Okay, address bus of microprocessor 8085. Now we know that in DMA controller, the address is stored in the memory address register. Okay, so it is a memory address register. The address is stored here. The DMA controller has to place this address on the address bus. And we also know that to our DMA controller, for example, if this is the DMA controller, so inside DMA controller, we have this memory address register, and we have to place this address onto the bus, address bus of microprocessor 8085. Now here we have pins. One set of pins is A0 to A7. Okay. Another set of pins are data pins that have the dual operation. They are used both as address pins as well as data pins. They are as a multiplexed pins. Okay. So lower order 8 bits are placed in these 8 address lines, lower order 8 bits. Okay. And from these 8, we place those in the lower order 8 bits of address bus. Okay. Now the higher order, these higher order bits, higher order 8 bits in the MAR register, they are placed on the data bus of this microprocessor of DMA controller through these 8 pins, DMA pins. Okay, data pins. Okay. Now we know that since it has the dual operation, it will go to a latch, and this latch will have a signal, like we have a signal in the microprocessor 8085 address latch enable. When that pin is 1, when that signal is 1, that means the data bus carries the address. And when that pin is 0, that means the data bus carries the data. Likewise, we will have a latch here, and that will be activated by another pin that of DMA controller, that is enable latch, address enable latch. Okay, AEN. So this pin will be activated, and that means these bits will contain the address. So these addresses will be given on higher order 8 bits of the address bus. Now, after placing the address on the address bus, lower order 8 bits and higher order 8 bits from this memory address register, we can go to one location in memory. Then from that location, we can send data from the DMA controller through the channels. Okay, so which channel should we choose? If this is an memory address register of channel 0, then we will use channel 0. If it is channel 1, then we will use channel 1. Okay. Fine. So the DMA controller, after placing the address on the address bus, the DMA controller continues the data transfer by, so after this, the fifth step is, so after placing the address, the fifth step is DMA controller transfers the data to the memory and also asserts necessary control signals. So it will also send the necessary control signals. For example, IO read, IO write, memory read, and memory write. Fine. Now, after that, after the completion of data transfer, this DMA controller sends a signal EOP that there is a pin, EOP pin, end of process pin on DMA controller. It sends a signal through this pin, and this will determine the data transfer completion. Okay, so this signal is sent to a peripheral device, so that peripheral device will know that the data transfer is complete. Now I cannot send more data directly to the memory. If I have to send more data, I have to again repeat the DMA operation and then send the data. So this is the complete operation that is happening while doing a DMA operation. Okay, so with this, I will stop this particular lecture here. But before stopping this lecture, let me repeat what we did. So we first understood the direct memory access concept. Then after that, we discussed the controller for DMA operation. And one such controller was D237A, D237 controller. And also in the DMA, we said that there are two main pins on the microprocessor 8085 that are used for DMA operation. One is hold and another pin is hold acknowledgement. So for this DMA control, for this particular controller, DMA controller, we discussed its pin configuration, not all the pins, but some of the important pins. Pin configuration, then internal registers, and we also discussed it as execution. There are many other details that are related to this 8237 controller. For example, programming of 8237, because we have not discussed anything about the programming, but if you have time, you can go through this particular concept as well. Okay, so this was all about the DMA operation, direct memory operation, and a programmable 8237 control, DMA control. Okay, so with this, I will stop this particular lecture. Let's meet in the next lecture. Till then, goodbye.